What's up folks, welcome back to my YouTube channel Code to Create. In today's video we're going to create a model that predicts if the comment is malignant or not. Or not in the sense if it's a bad or offensive comment or not. First I've imported all the necessary libraries up here. That is Panda first for reading our files and everything. And then we have NumPy for renaming all those things. We have Matplotlib and Seaborn for the plots. NLTK I'll show you guys why, and the string I'll show you guys why. This is also for renaming purpose. And then I have stop words. This is for a plot. And I have word tokenized. This is for tokenization of words. We have Porter Summer and WordNet Limitizer, and then we have word cloud. This is for a plot. And then we have vectorizer. This one we have imported by TF-IDF vectorizer. And then I have XGBoost, I have LE5, and then multinomial naive Bayes train test split for splitting our dataset. And then we have accuracy score, confusion matrix, classification report, ROC curve, ROC AUC curve, and AUC. And then we have train test split, and then we have accuracy score, confusion report, confusion matrix, and F1 score. This one, I guess I've imported it again, guys, so don't mind that. And then we have logistic regression, and then cross validation score and grid search CV. And then I've imported multinomial naive Bayes. And then I have decision tree, and then we have K neighbors classifier. We have random forest, AdaBoost, and gradient boosting classifier. And then we have Gaussian naive Bayes. We have logistic regression, SVC, and decision tree classifier. And then I've imported joblib for exporting our model. Let me run all these up. It should not show any error. Yes, we can see no errors, and now we have to read our train dataset and test dataset. So I've separated these both, and don't worry guys, I'll be posting this dataset in the GitHub link below. Let's read our dataset now. I'm going to say train df is equal to pd dot read underscore csv. I'll show you guys the dataset, don't worry. And this one is the train dataset, so I'm going to say slash train. And this one is our train dataset, so I'm going to say slash train.csv. And then I'm going to copy up the same thing. Let's paste it up. Yeah. And we have to change it to and we have to change it to test. Let's do the same up here. Test.csv. Okay. It says invalid argument. Let's see where it's showing this error. Train df is equal to pt dot read underscore csv. Comments project name dot csv. It should not be showing any error, and it should show yes, no errors. So I'm gonna say, let me show you guys the dataset. In test dataset we have id and comment text. We're gonna remove this id as we don't need it. I'll do that later. Now let me check our train dataset. Let me run this up. Yes, we have ID, we have the comment text, if it's malignant or not, if it's highly malignant or not, if it's rude, if it's a threat, if it's abuse, or if it's a load. And now let me show you guys some information about our dataset. So let's say testdf.info. And we can see we have object, both of them are object data type. Let's check our train datasets information. And we have object and integers. As we can see we have zeros and ones, that's why it's integer up here. And let's see if we have any null values. So I'm going to say testdf.isNull.sum. I'm pretty sure no, yes. Let's check the same thing in our train dataset. I'm pretty sure it will not be. I'm pretty sure there's no null values. Yes, no null values. Now let's get our correlation of trained data set. So I'm going to say print. Now let's get our correlation. So I'm going to say print train df dot correlation. I'm going to say print SNS, that's C bond, SNS dot heat map. It's a type of map. It's a type of plot actually. It's a type of plot for checking correlation and many other things. Train df dot correlation. And we can see that everything is normally correlated. And next we have to check our skewness. So I'm going to say train df dot q, if it's right skewed or left skewed. And we can see most of them are normally skewed, so we don't need to worry about the skewness. And now what we have to do is we have to check our value count and check which one is more. If the comments up there are more of malignant comments, or if they're highly malignant comments, or if they're rude comments, and so on. So I'm going to say column is equal to malignant and highly malignant or loath or rude and abuse or friend. And then I'm going to create a for loop. I'm going to say for I in columns, for I in these columns up here. I'm going to print I first. And then I'm going to print the value counts. I'm going to say train df of I dot value count. So of all these columns, every single row dot value counts. And then I'm going to say SNS dot count plot. Train df of I. So we're going to plot this up. And then I'm going to say plt.show. So plt is basically matplotlib, and when I say plt.show, it shows the plot. As we can see up here, we have our malignant, highly malignant, loath, rude, abuse, and threat. And if we look into this, let me make it a bit small so you guys can see. Yes, malignant, highly malignant. We can see most of the comments are of malignant comments. Now what we have to do is we have to clean our data set. So wherever we have all these symbols, we're going to put it to email address. Wherever we have all these numbers and all, we're going to put it to numbers and all those things. So I'm going to say train df of comment text is equal to train df of comment text dot str, that's the string dot replace, and I'm gonna put all these up, all the symbols that are there for email address. And yes guys, we can see I've renamed almost all of the things, that numbers, dollars, everything. So this have email address, these are all symbols, and then we have web address, we have this HTTP and all those things, and then we have dollars, all these things. And then we have phone number, all these symbols, we have number, all these symbols, and rest all we've put it as empty string. So now we have cleaned our data set in the train data set. We have not cleaned it in the test data set. So let's do that. I'm going to say test df dot. I'm going to say test df of comment text is equal to test df of comment text dot str dot replace this one. All of this, and we're going to replace them to an empty string. And then what we have to do is we have to get all the words that are offensive. from these comments. Yes, you can see it's completed and there are no errors. Now let's print out a plot that shows all the offensive words. So I'm gonna say hams is equal to train df. I'm gonna get all these offensive words one of comment text train df of oh. And then I'm gonna say train df of malignant is equal to 1. And then I'm gonna say spam cloud. I'm gonna add a bit more offensive words, so whenever we get another comment also it can classify them up. So I'm gonna show basically most of the offensive words. So I'm gonna say spam cloud is equal to word cloud. I'm creating a class with the width of 600. It's basically a plot, so I'm gonna put the width and height to it. So I'm gonna say width is equal to 600 and height is equal to 400. And can I set the background color to black, so all the other words could be seen. Black. And the max offensive words, I'm gonna put it to 50. And then I'm gonna say dot generate. And to this we're gonna join the offensive words that are there up in this comment text too. I'm gonna say dot join hams. And then I'm gonna say plt.figure. PLT is basically matplotlib. I'm gonna say plt.figure. Figure size, I'm gonna set it to 10. I'm gonna set it to 10 and 8. 10 to 8, and then I'm gonna set the face color to okay. I'm gonna show this plot now. I'm gonna show this plot. So I'm gonna say plt.imshow. This imshow is basically image show. We're gonna show this spam cloud. And then I'm gonna say plt.axis. I'm gonna set the axis to off as we have no y value up here. It's just like an image actually. So I'm gonna say plt, and I'm gonna say plt.tight layout. Yes. I'm gonna say plt.show now. It should not show any error. There should not be any error actually. Yes, we have all the offensive words. And now let's see how much percentage of our comments are malignant, how much percent of comments are highly malignant, how much percent of comments are rude in our total data set. So that goes with a pie chart. So I'm going to say df of distribution is equal to train df of target. I'm going to say train df of what we have named it up here is, okay, I should have renamed it somewhere. We have all of these. Yes, we have up here, so it's a column. Df of column, train df of column dot sum. And here most of the people create errors, guys. Check this out. Leave some space and then let's just get it up here, and I'm going to say dot to frame slash space, rename columns with the count, and then I'm going to put slash leave space dot sort values. I'm going to put the count up here. And then I'm going to say df of distribution. df of distribution dot plot dot by y is equal to count. We're going to set the y to count. And then let's set the title up here to label distribution over comments. And I'm going to set the figure size to 5 to 5. And here another slash. I'm going to say dot legend center left. Let's make it to center left. And then I'm going to set the B box from the center to 1.3 to 0.5. Yes, so let's run this up. We have an error. Okay. So where is this error? This should not make any difference, but let's just see it out. I'm gonna do this. Let's run. Yes. So I don't know why it made a difference, but let's just leave some space up here. And we can see 50% of our comments of Malignant, as we are classifying that, of course. And then I'm going to create a class for this stemmer and lematizer. So I'm going to say lematizer is equal to wordnet lematizer. And stemmer is equal to Porter stemmer. Let's run this up. And after this, we have to use lematizer and stemmer for our comment text column. So let's do that. First, we have to create a loop. I'm going to say for I in range of length of our test df of our comment text in this test df. I'm going to say test df of comment text of I is equal to test df of comment text of I dot lower. So we are basically going to lower all our text in this column. We're going to put it into a lower case, and then after this I'm just going to create a variable that's j, and I just took it like randomly j. You guys can take anything, that doesn't matter. Like you can take a, b, c, anything other than I, of course. And inside this, I'm going to create another loop. I'm going to say for word in test df of comment text. So for each and every word in comment text of I dot split, I'm going to say j dot append lematizer dot lematize. So we're basically going to lematize up here. Lematize word. Yes. I'm going to say test df of comment text of I is equal to dot join j. So now we have completed lemmatizing this up. We have completed lemmatizing our column. Let's copy this up and do the same for our training data set. Yeah, so I'm gonna say train up here, train. Yes, everything is right. Let's run this up now. And it takes some time to run, so no problem up there. And now what we have to do is split our data set. So I'm going to say x train, remember this order guys, comma x test, comma y train, comma y test is equal to train test split of x, comma y. Oh, okay, guys, we forgot one thing, that's creating our x and y variables. So I'm going to say x is equal to df dot drop Malignant, and let's set its axis to 1. Oh, yes. And then let's set our y variable to Malignant. Let's run this up, and here the random state is going to be 42. And so for this model we're going to use naive Bayes. So let me just create a class for this naive Bayes. So I'm going to say naive is equal to, so we're going to say naive is equal to multinomial NB. Yes. So guys, we've done a small mistake again. What we have to do is we have to use the vectorizer for this x. So what I'm going to do is I'm first going to create a class for this too. Let's do that. Yes, we have created a class. Now I'm going to set the x. So I'm going to say x is equal to tf dot vectorizer, tf of x is equal to tf of vectorizer dot fit transform comment, and then I'm gonna say naive dot fit here itself. I'm gonna say naive dot fit x train comma y train. Let's run this, and then we have to predict. So I'm gonna say y predict is equal to naive dot predict x test. Yes guys. And now the final thing, that's exporting our model. So I'm going to say joblib dot dump y predict comma, I'm going to save this as model. So after all this get completed, I'm going to show you guys at the end, and I'm also going to show you guys the prediction up here. So let's wait till it gets completed. Okay, so when everything got completed, I've seen an error up here that says df is not defined. So what we have to do is put it as train df. Now let's run. Yes, let me run. Let's just create a class, let's just create a small variable. Comment is equal to df of comment. Oh, train df of comment. See error comment text, Yes. Now let me show you guys the y prediction. Yeah, it's basically a array, and it's shown in zeros and one. As it's in zeros and one, zeros means no, it's not malignant. One means yes, it's malignant. So yeah guys, now we know how to create a model that predicts if the comment is malignant comment or not. Thank you friends. Please do like, share, subscribe and comment below. Bye bye.